Okay. They want us to see if these lines are parallel, perpendicular, or neither. So what it says, review 3-7a, chapters 3 through chapter 7a is what all this stuff came from. And chapter 3 was a lot of algebra stuff. So we might not be fans of algebra. That's totally cool. Whereas some of it on the final, I am totally not lying to you that things we're going over are on the final for sure. Cool. So they say determine whether these lines are parallel, perpendicular, neither. See what we remember. What do you know about parallel lines and their slopes? What's true about parallel lines and their slopes? They got the same slope, right? Remember, perpendicular, that means they intersect at a 90, but the slope, two words, that's where the signs are different, and you flip it over. You know what those two words were? Opposite reciprocals. So, to find out if line AB or line CD are parallel, perpendicular, or neither, first let's find the slope of line AB. So we'll show the work. Remember, M stands for slope. If I'd use a pen, that'd be better. Slope of line AB. Could you go to your yellow card and see that that formula is on there under the linear section? Like, look at all those things on your yellow card for linear. Who's on top, the X's or the Y's? And just because it's been so long, remember, this is X1, Y1. This is X2, Y2. So do you see how we're going to do like Y2 minus Y1? So 4 minus 5 over X2 minus X1. Wouldn't that be 4 minus 1? Been a while, but you've also done this numerous times in your math life. So we're okay with that setup. What's 4 minus 5? -1. And what's 4 minus 1, baby? 3. But see, those easy little sign things is where having a partner is awesome, because it's like, oh, my bad, sign error, you know, kind of thing, and multiple choice. So that's why you want a partner. Now, before we find the slope of line CD, let's talk. If these lines are parallel, what should the slope of line CD turn out to be, knowing that AB's slope is -1/3? What does it have to be? It's parallel. The same, -1/3. What about if they were perpendicular? Who is the opposite reciprocal of -1/3? And that's where I wanted to bring this up, is because a lot of people are unsure. They think you need to change both of these signs. You do not change both of those signs. I'm going to ask you this question. What is the sign of this number right here? Is that a positive number or is that a negative number? That is a negative, right? So the opposite of that is a positive. We would have a positive 3/1 if these were perpendicular. Does that make sense? Like, you don't switch both signs. You switch the sign of the entire number. Cool? So find the slope of line CD. I'll let you pause the video to do. So, main reason I wanted to go over this guy, though, is because this slope looks like it's like 5 over -15. Did you get like 5 over -15? And then some people go, well, those are not the same and they're not opposite reciprocal, so I'm going to put neither. Obviously, that's one of the choices on the multiple choice test. But of course, the trick is, can 5 over -15 reduce? What is 5 over -15 reduced to? -1/3. So are these lines parallel, perpendicular, or neither? Parallel, and if you had to justify, give me 2 words. Why? How did you know they were parallel? Because same slope. Cool. Same slope. I'm going to make up another one just for fun. Let's say you had the slope of line, you don't have to write it down, just watch. Slope of line AB, let's just say it was like 3/7. What would the slope of the line perpendicular to it have to be if this guy was 3/7? Talk about it with your table. Like, what would it have to be? What do you want? -7 over 3. You see the opposite reciprocal. But wait just a second. What if it was this? What if it was just a positive 7/3? My question is, are these lines parallel, perpendicular, or neither? If one slope is 3/7, the other one is 7/3. What do you think? It's neither. They're only reciprocals. They have to be different signs, and they have to be flipped over to be perpendicular. Cool in the game? All right, that's a little bit of algebra. Here's a little more. They say write the equation in point-slope form. Here's why. Just kind of refreshing your memory. Remember, that's the whole point of this. What is that thing that I've highlighted in pink? What is it trying to tell us? We have what? Slope of 2. So we pulled out, we're given the slope. And how do you feel that this dude right here is a point? All right? Go to your yellow card, find point-slope form of the line, and let's sub in. I could care less if you wrote this formula down, but that is the formula, right? but let's sub in. Remember, x1 and y1 were the points that they gave you, and m is the slope. So let's sub on in. Okay, so did we put the numbers in the right spots? Are we okay with that? Now, this is not the final answer that they want. They want it in slope-intercept form. So let's do this. Tell me what this is called. Boom, boom. What is that called right there? What's that called? Distribute, right? So let's distribute that through. You can do it, guys. Maybe you're already there. You were going faster than I thought. But then we got to get y all by itself. And what's one move to get y all by itself? Add 11. And this is why having that partner would be awesome, because if you had that, you just subtracted 11 from both sides, not add 11 from both sides. So they help you catch those sign errors. So shouldn't that be +5 in that case? Cool. Again, been a while, and algebra is probably not your favorite subject in the world. This is called slope. This is called slope-intercept form. Y equals mx plus b, and this is called slope. Cool. So let's do that again once you get me started. First, I want to fix this to make it easier for us. Let's change this -12 to a +3. That'll make the numbers come out a little bit better. And talk me through it. Okay, he's trying to teach you stuff you already know how to do. I'm just trying to refresh your memory. They want me to write the equation of the line that goes through these 2 points. What do I need first? What do I want to find? Find the slope. All right, so let's find the slope. Did you get a +1 for the slope in that situation? All right, so cool. But that's not what they want. They want me to write the equation of the line that goes through these 2 points. So we have a slope. Do we have some points also? Right? So we can use point-slope form. Which point should you use? It doesn't matter. Pick one. I always like to circle it, so I'm going to use that one. I always like to circle it. You could use the other points and use the same formula that we just did. That's point-slope form. I could care less if you write this guy down. I'm just showing you that's the formula that we want. You pick a point like this one. I'm going to use this point and use that slope and do point-slope form to put it into slope-intercept form. So sub them in. So I have subbed those guys in. Here's the slope of 1. And then the point. It's just like a little opposite game. It's kind of weird that it's a 1. You really get the same thing back, you know. Not the most exciting stuff in the world. I'm a much bigger fan of geometry than algebra for that, because to me algebra is boring. But it is on our finals. We did cover it this year. If you have more questions about this, I'm happy to help you later today. But that was just my little algebra refresher from chapter 3. I don't want to go to the next slide because I have some stuff written on there that I'm going to ask you about. I want you to just do the next one with your neighbor. And here's what I'll talk you through. What did they give you? Can you mark that? How is it possible? And then what do they want? All right, so talk that out and let's see what happens. So what I'll do for the next question is turn it into multiple choice after you've already thought about it, right? This is my multiple choice question. Kind of hard to see from a distance, sorry about that. But you've got A, B, C, or D. Which one of those do you feel, discuss with your table, should be the correct answer? And then what's also cool about multiple choice tests is you don't have to remember every single little detail. Like you may have forgotten how to write some of this stuff down. You don't have to. You just have to read it properly. So let's do this. Let me teach you how to approach this problem. What's similar between choice A and choice B? What do they have that's similar to each other? They both start with parallel lines. And how about C and D? They don't start with parallel lines, but they end with parallel lines. So in process of elimination, when they give me this, which one of those 2 concepts should I do? Starts with parallel lines or ends with parallel lines? So that means see ya, I can eliminate those. Then it comes down to what kind of angles are we talking about? 2 and 6, what kind of angles are those? Are they corresponding angles or alternate interior angles? So, bada boom! You see how you don't have to know everything. You have to learn how to use a multiple choice question to your benefit. You know, it's like what's similar, what's the same, what can I eliminate? Cool. All right. Then some serious old school stuff. This was the day where I broke out some spaghetti and tried to make a triangle out of 3 pieces of spaghetti all the time. And it doesn't work every time. Sometimes the pieces were too small or too large. Here's the general rule. If I had pieces of spaghetti right here that were 8 inches long, 5 inches long, and 2 inches long, I want to see if I can make a triangle out of them. I got to pick the 2 smallest ones. Who would they be? The 2 and the 5. If I put them together, they're supposed to be, do you remember in relation to the third side, they're supposed to be either equal, less than, or greater than. One of those 3 things is right. What do you think? They have to be, good thing we're reviewing, longer than it. So let's do the math. Follow my lead. Who are the 2 smallest sides? Let's add them together. 5 plus 2, 2 plus 5. And then this should be greater than the third side. You see how I used an algebra symbol of the greater than. I also asked you to prove this to me like I'm a kindergartner. So I don't want to have to read this. I want to clean it up. What is 5 plus 2? I can simplify that. What is 5 plus 2? 7 greater than 8. And now you ask yourself this, yes or no? Is 7 greater than 8? No, it is not. So the answer is no. If you had this little bit, so sorry I skipped that, but let's do another one. Who are the 2 smallest sides in number 6? So we'll add those together and see if it's bigger than the third side. And a little bit of arithmetic. What is 5 plus 12? And then, of course, yes or no, is 17 bigger than 13? You could make a triangle out of those. The 13 would go like on the bottom for a base. You'd have a 5-incher and a 12-incher, and you'd reach them down, and they would touch. They would touch, and they would make it work. Please do the other 2. See if you can make a triangle out of those. Show the algebra. So I got them set up. 6 plus 9 is 15. Is 15 greater than 20? Yes or no? So that's a big fat no. It wouldn't work. And 8 plus 9, I believe that is 17, correct? And that is a yes. I'm going to change this last one. What if that side wasn't 13 and it was 17? What do you think? Yes or no? Is 17 bigger than 17? Not. You have those pieces of spaghetti at the bottom when you put them on the ends and they would just pull flat right on top of it. It wouldn't make a triangle. It has to be larger than the third side in that case. So that would still be a no. Cool. And then we did this also. Which angle must be the largest? There is a mathematical theorem behind it that says, hey, if you know all the signs, like the largest side, it's going to be like right across from the biggest angle. The smallest side is across from the smallest angle, and the medium guy is across from the medium. So 2, 5, 6. Who's the biggest side length? 6. So right across from that should be the largest angle. And let's not just put P, because P is a point. Can you make it say angle P? Like that. Are you cool that the largest angle is across from the largest side? So do a similar thing on the next one. They ask which side should be the smallest. Uh-oh. They didn't give me all 3 angles. They only gave me 2 of them. Can you find the third one? They all end up to how much again? 180. So do a little subtractifying. And what does that third one turn out to be? 58. So watch this multiple choice question. Who is the smallest side? Please let me write them all down first. Multiple choice. Who is the smallest side? This one says ray ML. This one says segment ML. This one says line ML. And this one says the distance ML. Oops. What's the side of the triangle? Is it a line, a ray, a segment, or a distance? Segments. Are you with me on that? So it will be that. So just because you think you know, sometimes it's like, holy cow, they all say the same thing. I remember multiple choice can be tricky. Cool. So segment ML was the answer to that. Or LM. They could have switched them around. Rock on. Then we need to cover Chapter 5. I forgot to put that on this worksheet. I made this worksheet this morning. I was in a hurry. I was like, hey, what do we need to talk about? So I was in hurry. I forgot about Chapter 5. So we're just going to talk about it out loud. Chapter 5 is proving triangles congruent. 5 ways to do it. First one I'll tell you, side, side, side. What's the other 4? What's the next one? Side, 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 side. There is side, angle, side, angle. And then that weird one. Does it have 2 A's in a row or 2 S's in a row? 2 A's. So it's what? Angle, angle, side. Remember, you'll never have 2 S's in a row unless you have all 3 S's. So there's no ASS and there's no SSA. Then there's one really weird one. Who's the really weird one? Hypotenuse leg. But that was proven triangles congruent. Exact same size, exact same shape. That is not what we're doing here. They are asking us to see if these are similar. So remember, I'll write a similarity statement here also because we didn't talk about that right here. So first thing first, I got to prove them similar. Let's write these down because it'd be cool so you don't have to go digging through your notes all the time. There's 3 ways to prove triangles similar. This way, it's called angle-angle similarity. This way, side-side-side similarity. And this way, side-angle-side. So what we were just talking about, those 5 ways, is to prove them same size, same shape. We're not doing that here. We're proving them similar. That was like your scaled model of a car versus the real model. Isn't there like a scale factor going in those two? So before we go through all that work, we needed to prove it. So first thing first, what the heck are those? What's going on with those? Those are parallel lines, right? So stop at 27, Evie. In the worksheet, 27 is the last one to do. Okay. So these are parallel lines. Cool. Got a question for you. What if I had this orange segment right here as like a transversal? Does this arc mark right here touch that parallel line in green and touch that orange transversal at the same time? Go ahead and mark that. Can we do that again using the other parallel line, the other green one? Can you make an arc mark that touches the other green parallel line and also touches that orange segment? If so, do it. And real quick, is it right here? Yes or no? That doesn't touch the orange one at all. That's not the right place. Is it right there? Cool. Let's see what kind of angles those are. Are they on the same side of this orange here or on alternate sides? They are on alternate sides. Are they between the green parallel lines? Those are alternate interior angles. And since we have parallel lines, shouldn't those be the same? Could you do that again, but with a blue transversal instead of an orange one? But remember, you got to put double arc marks instead of single arc marks. And I'll bet that's like right here. Is that okay? Those are also on alternate sides of that blue guy in between those green parallel lines. And question, is that enough to prove these 2 triangles similar? Do they have 2 sets of angles the same? Yes. The minute your brains were going, what is easy? What kind of angles are those that are right across from each other in X? What kind of angles are those? So you can do that all you want. It's all good in the neighborhood. You will have all 3 sets of angles the same. You just don't need it. You need 2 the same because the third one's provided. Once you know 2, you can always find the third one. So are these guys similar? Yes. By which method? Angle, angle. And I'm going to assume that back in the day, that was your favorite one of them because you didn't have to find any side lengths and find their proportions and see if you got the same scale factor back every time. That was a pain in the butt. But regardless, they're going to make us find the scale factor. So before we do that, let's write this similarity statement. One of the homework questions today had this on it, and the kids were like, how do you do this? How do you do this? So the similarity statement, let's name this triangle right here, triangle EFG. Cool. And I'm going to run out of room here, so I'm going to go to the side a little bit. We don't want this symbol. Please tell me what this symbol says. What is that symbol that I just wrote down? That says what? That's congruent. We don't want that one. We want similar. Do you remember that D is just this guy right here, just the squiggly part, just the tilde. So who does E correspond with? Well, E's got that single arc mark in it. Shouldn't we go with H that has that single arc mark in it as well? Finish this guy up. So triangle H. F goes with I, and G goes with G. Are we okay with those? Right? So the reason I brought that up is a lot of people are like, what does that mean right there? What does that mean? Similar to each other. They are similar. So to find the scale factor, I got to find two sides that correspond to each other and know both their lengths. I've always called these the bow tie problems. So you can look at this picture, kind of looks like a bow tie. And you see the green things, which are like the parallel lines. Those are what I call the edges of the bow tie. They always correspond to each other. So the edge corresponds with the edge. So then check this out. It's pretty likely that since these are the only two numbers that they have, we have like a 5 and a 2 that they're going to go together. But here's how you know for sure. Is the 5 between the single arc mark and the triple arc mark in that case? He corresponds with who's between the single and the triple. And then there was one other thing that made our life so easier back in the day. We did this. We put a B and an L in this picture for the big triangle and the little triangle. Could you do that on the inside of these triangles? Which one's the big one? Which one's the little one? We cool with that? So let's write our scale factor. What would our scale factor be? Two sides that correspond to each other, we know both their lengths. What do you want? 5 and 2. So how do you want to write it? Like, what do we want to write? Like, just 5 and 2? 2 over 5, 5 over 2? What would you like to do? 5 over 2. Should we change it to 2.5? We will not change it to 2.5 because we want to set up a proportion to find the missing guy. So we start with our scale factor, and then we're going to set it equal to whoever x corresponds with. Who does x correspond with in this picture? X goes with the 4. Hey, how would you like to write? 4 over x or x over 4? It has to be 4 over x because of our little rule that we made. Don't we do big over little every time? So 4 over x. And remember how to solve a proportion. What do we got to do to solve a proportion? Let's cross multiply, baby. So we will take this times this. And then remember, you just bring the equal sign down, and you take 2 times 4, and that is 8. And this does not come out nice. You can leave it as a fraction or leave it as a decimal. I don't care. Let's just do decimal, huh? Since it's a clean decimal. 1 point what? 1.6. If it doesn't come out nice, leave it as a fraction. But that was a nice clean decimal. Long ago, right? Scale factor and proportions. Couple of more things real quick. Oh yeah, I forgot about this guy. Let's realize what I'm trying to do with this. This quadrilateral hierarchy, bro, in no way am I going to ask you to draw the whole thing and write all that stuff on there. That's just crazy. Unless you're like the super mystic kid that gets that one final that does have it on there. Which I've had to do in the past. It's horrible final. Please don't go that far. You're a long ways away from that. But we're going to use the quadrilateral hierarchy to answer a bunch of multiple choice questions. So I could care less if you use a straight edge off to the side. You can freehand this if you want. You remember making the pair pants? All right, let's make a little pair pants. So you can freehand it. Try to make it pretty, though, because you're going to have to read this thing. But straight edge helps. You don't have to use it. This is just you on your test trying to answer a bunch of questions about these shapes and their diagonals and all that other stuff. And then kind of the whole reason why we drew this, we got to know where the shapes are. It's been a long time. It was back in December when we did this. So let's go through my process of just like, okay, this one's here for sure. Who has to be up here in the quadrilateral hierarchy. That is the quadrilateral. Don't even care about you spelling it, right? Because we're just using it to answer some multiple choice questions. So I'm going to abbreviate it. That's the quadrilateral. Cool. Do you also remember who the most specific guy was, like all the way down at the bottom? Who was that? He is the square. Remember, hierarchies go from least specific at the top to more and more specific as you go down. Then I've always taught this. There's also this one oddball in the family. He was way out here in left field. Do you remember who that guy was? The oddball way out in left field. He is the kite. And then the reason why I do those 3 first, 1, because they're kind of basic, but 2 is because everything else is one of those guys. It has at least one pair of parallel sides. Who is this guy right here? He is the trapezoid. everything underneath that will also have at least one pair of parallel sides. So then we just kind of go down here. Who was this one? The more specific type of trapezoid. He is isosceles trapezoid. And then in all seriousness, I think this was the worst one that we couldn't remember who that guy was in that spot. So let's go through the three that are remaining. We have a rhombus, a rectangle, and a parallelogram that we're still missing. Who's the one in the middle going to be? That's the parallelogram. He's got two pairs of parallel sides. Again, I'm not asking you to rewrite the whole thing and spell everything correctly. It's multiple choice type questions. Two of them left. Rectangle and the rhombus. Who's the one that goes on the right? It's the one with 4 right angles. Who is that? That's the rectangle. That means this dude is the rhombus. But this is really not what the questions are going to ask you about. You got to kind of know where they're at to answer. A lot of them are going to be about the diagonals and what's true about them. And I had a phrase, the 3 magic letters were P, B, and E. Remember what those I use for my acronym. Peanut butter every day, or whatever. It doesn't matter what what matters is you remember that it's P, B, and E. So they go right here, brother, straight across. P, B, E. Straight across. But let's discuss what they stand for, because if you don't know what they stand for, this is worthless information. This is about their diagonals. What's true about the diagonals of the kite? What does P stand for? They are not quite parallel. That's a very good P word, but it is perpendicular, right? So that means they intersect at a 90-degree angle. So if you had a kite, which that's a kite right there, aren't these diagonals boom and boom? They intersect at 90. That's what that means. What did the B stand for again? Bisect each other. They cut each other into 2 equal pieces. And E, of course, was what? What? Just equal. They're the same length. So if you have an isosceles trapezoid right here, bada boom, this guy is the same length as this guy. What's true about these? These are what? Equal. All right. So now let's use the hierarchy to figure out what's true about the diagonals of a rhombus. Pretty simple. Bring them down. What's true about the diagonals of a rhombus? They should be perpendicular bisectors of each other. What is true about the diagonals of a rectangle? Bisect each other. Anything else? They are equal. They're the same length, and they cut each other into 2 equal parts. And here it is, my old early 2000s joke, the squares like Stacy's mom. Got it all going on. How many letters go down there? PBE. They are perpendicular, they bisect each other, and they are equal. And in all kindness, if you miss a question about the diagonals of any of these quadrilaterals, it's shame on you, because it's all they're asking you. Which one of these are only perpendicular? Could you figure that out right now? Of all of these, which ones are only perpendicular? Discuss with your neighbors. What do you got? This is the only one. The other ones have some P's. Do they have other things going on with them? Right? When I say only perpendicular, it is just that way. Is that cool? Which of these have nothing fancy? We haven't wrote any of that down. Which ones have nothing fancy? The trapezoid and the quadrilateral. Are we cool with this? All right. 2 concepts left, baby. This one we should dominate. Could you draw a picture of that? Let's use a straight edge this time. Let's draw a picture of that real quick. Give yourself room to do some else. So here's my picture. I didn't actually draw a real tree. I just drew a segment and put the word tree there. Things I assume true. Ground is flat. Tree is straight up and down with the ground. Starts with P. Put it in 90 degrees. What's the word I'm looking for? Did they tell you how tall the tree was? 30 feet. And then we also discussed in detail where shadows are located. Where are shadows always located? On the ground. Are we cool with why I put the numbers in the place that I put the numbers? They ask us to find the angle of elevation. If I mention that word, I got a question for you. Does that mean up or down? Angle elevation. Up. Up from where? Up from the horizontal. So how do you feel that that is a horizontal in this picture? And we want to go up from that inside the triangle. So let's put that weirdo symbol. What is that thing called that when we don't know an angle? What's it called? Theta. And since we have a right triangle, guess what our process is to solve for this missing angle measure? What's our acronym that we use all year? So focus all your attention on theta. Figure out which one of those is the 12 opposite, adjacent, or hypotenuse. Is the 30 opposite, adjacent, or hypotenuse? And then we'll figure it out. Are we cool that 12 is adjacent to it? He's touching it, but he's not the hypotenuse. And 30 is the opposite. How do you know where the hypotenuse is? He's across from the 90. So which trig function deals with opposites and adjacent? It's even cool if you don't even remember what it's called, if you just know if it's the S1, the C1, or the T1. You know what I'm saying? But I try to train you if you're smart enough to know what it's called. Which one is it? Tangent. Thank you guys so much all year for listening and buying into that. I think that will pay off on your ACT if you choose to take the ACT. The tangent of the angle measure should equal, do you want to do 30 over 12 or 12 over 30? Opposite over adjacent. And then what's that thing called that I got to do to make things switch around from a -1? What's that thing called? The inverse. To me, that's why I wanted to do that in chapter 8 also, because it made refreshing this a breeze. We just did this in the previous chapter with our angle of returns. So you punch that in, and then did you get to the nearest degree? Let's do the, sorry, my calculator's not open, but it turns out to be 68 degrees. Is that what we're getting in that case? Please make sure you can punch that in. The other thing that I beg so much of you is that before we take our final, please remind me to check if our calculators are in the right mode. Because, man, it sucks when you're in, like, radians instead of degrees. So we'll all punch in a number. Then, man, I wish we could stop, but you will be very happy that we refreshed these special right triangles. Remember 30, 60, 90, and 45, 45 members of right triangle. So let's talk about this dude right here. You see this side is 9. How long should that side be right there? Based off the tick marks, doesn't he have to be 9? You didn't even need any kind of real math skills besides knowing what the tick marks were to figure that guy out. But they also asked for the exact length of this guy. So my question to you is, which one of these special guys is it? 45, 45, 90 or 30, 60, 90? Since he's isosceles, what has to be true about those two angles right there? They're the same. And since that's 90, shouldn't the other two have to add up to be 90? So 45 and 45. Isn't this a 45, 45, 90 right triangle? So our memories are like, okay, there was a bunch of radicals with these guys. Some of them had radical 2s, and some of them had radical 3s. So here's my secret. How many sides are the same in this triangle? 2 or 3? 2. So this side will be the 9 with a radical 2 next to it. When you have the leg, the hypotenuse is always radical 2 times as much. On this one, this is another leg. Do you see how he is 45, 45, 90 because of the tick marks? If this is radical 7, shouldn't that side be radical 7? And we have to take radical 7 times radical 2 to figure out the hypotenuse. It's okay. You can totally multiply radicals together. Just pretend there were no radicals for a second. What's 7 times 2? So radical 7 times radical 2 is radical 14. Are we okay with multiplying the radicals together? And then the last one of these, he is also 45, 45, 90. Do you see the tick marks? Right? But who's this? Leg or hypotenuse? That's the hypotenuse. I got to go backwards and find the leg. Instead of multiplying by radical 2, you have to divide by radical 2. What's 5 radical 2 divided by radical 2? Shouldn't that be 5? But that was only 45, 45, 90s. I know I'm going fast through this. I will definitely help you with these later if you need help with them. But we also had 30, 60, 90s. Let's draw this together. You'll thank me so you don't have to dig through a bunch of notes. Let's draw this little 30, 60, 90 right here.
And I need you to put 3 little letters next to this guy. Who is that?
Short leg, long leg, or hypotenuse?
That's the hypotenuse. He's across from the 9. And the serious question of the day is, why does that one have to be the short leg as opposed to the long leg? How do you know that that's the short leg? Across from the smallest angle, which is the 30, right? So short leg, that means this guy is the long leg. Here's the ratio. We're going to make up any number we want for the short leg because he's the key to the puzzle. I'll call him 1. Cool?
And then again, I'll probe you in the right direction. Go to your hypotenuse and put the proper number, knowing that the hypotenuse is twice as big. If the short leg is 1, the other is twice as big.
How long does that one have to be? 2. And then it's down to those radicals. Remember, some of these had radicals with them. It ain't the radical 2. Who is the radical in the 30, 60, 90? Not radical 2, but radical 3. It's the short leg times radical 3. So it would be like 1 times radical 3, which the 1's probably not that important. But if that was a 7, that other guy would be 7 radical 3, and etc. So let's do a couple. First of all, you got to ask yourself, is it 30, 60, 90? And that answer is big fat yes. And then you got to go, who is this?
They give you one of the numbers. Is that the short leg, the long leg, or the hypotenuse? Who is that? Hypotenuse. That's us. I got to have the short leg.
So I got to go backwards. How long should that be, knowing that there's a 2-to-1 ratio with those? If that guy is 8 and I got to go backwards, how long should this be? 4. Half as much. Now that you have this, this is the key to the puzzle. So this one, 4 square roots of 3. Yeah. Am I correct that you don't have a number on number 5? There's a side length missing? Cool. Let's call this, 5 is fine. We'll do 5. Please find the other 2 guys.
Help each other out.
But that is the short leg right there. So that's the key to the puzzle. Doesn't matter which one you find first. The hypotenuse is twice as long, and the long leg is radical 3 as long. And then the real question is, why is this guy the long leg? Why is that 11 radical? It has nothing to do with the fact that he has a radical 3 with him. Why is he the long leg? Because he is across from the 60. Who do we need first? Short leg. So go backwards and make that 11 by dividing by radical 3, and then that's twice as long. I know this was longer than I thought it was going to be, but watch how fast your homework takes you today. It should not take very long. We're doing questions 9 through 27 is what we are doing. 9 through 27.